everyone, this is a quick video for the chi-square test of independence. I'm going to do two videos side by side, so I'm actually going to draw a little divider line for each of the two videos because these two tests are super related and can sometimes get confused for each other. So the first one I'm going to do is chi-square. Actually, let me write it, the symbol chi-square for one sample, and then the second one I'm going to do in a follow-up video is a chi-square for k samples. So for a chi-square for one sample, in this situation we have one population that we are considering, and we have j total responses. Number of responses. Where we have Pj is the proportion of responses that are in category J. So I'm going to just put in category J. Where J is equal to a number between 1 all the way up to capital J. So for a one sample chi-square test, we have a hypothesis, H0, which is equal to P1 is equal to sum P1. I'm going to put it as star to indicate like the hypothesized value. P2 is equal to some value, some hypothesized value, all the way to Pk, this is capital K, is equal to some hypothesized value. And then the alternative hypothesis, HA, is at least one. Actually just going to write otherwise. So one of these is significantly different from the hypothesized value, so just otherwise. Now we have a test statistic. I'm going to denote that with a capital X. So since this is a chi-square test, I'm going to denote it as x squared as our test statistic is equal to the sum of all j categories, so lowercase j equals 1 to capital case J, oj minus ej squared, that's on the upstairs or the numerator, divided by ej, and this is our test statistic, and it is distributed chi-square with capital K minus 1 degrees of freedom. Now in this notation, OJ is the number of responses for category J, and EJ is equal to N, which is the total number of observations that we have, times PJ star, which is the expected number of expected responses. For category J. So it's pretty typical that EJ is going to be the same for all of them because it's really typical that our null hypothesis is that all these probabilities are equal to each other. That's a pretty typical setup in a chi-squared one sample test. Not the only setup, but it works. And then we would reject H0 if x squared, our test statistic, is larger then some chi-square value, k minus 1, at level alpha. So, an example of this would be possibly example sample, let's do ask 30 students from a university what their major is. What their major is. And let's say the options. For some reason, we're only going to consider a few options. Just say the options were science, statistics, music, and English. Then we would have n equals 30 in this situation. And we would have capital J, which is the number of categories, is equal to 4. And then you would calculate the rest of the information based off of the actual responses that you got.